data increased. The methods that we know which can work on this kind of data, that has also increased a lot. So when this happens, then you need people to do both, right? You need people to handle large amounts of data, not just large amounts of data, any amounts of data, right? What do you do if you have a set of transactions that are happening on your business? What value can you build from that? Can you ensure that the next transactions are more profitable than the ones that went by? So everybody is suddenly starting to look at the data either they have or they want to get, and then apply some sort of an analytics on a layer on top of that, all with a view to get some insight which will eventually either grow business or help them in some way to ensure that future business is profitable. With this, let's look at a few specific. Let's look at a few specific examples of analytics, and before I go on to give you a flavor of a breakdown of an entire application end to end. For example, if you're a retail store, you could analyze the demographics of your consumers, you could analyze their preferences, you could analyze their spending habits, and put all of this together and predict which of the products are going to succeed if you launch them before you launch. And that has a large role to play on what gets eventually displayed on a store, either a physical store or an e-commerce store, right? So before you even launch a product, you're trying to forecast whether it's going to succeed or not. In the finance domain, again, there is a lot of application of having large amounts of time series tabular data where you're tracking the price of assets. It could be stocks, it could be bonds, it could be various types of assets, and their value varies over time. And the interest here is to understand if there are any patterns, any things that we can understand, which will build the alpha, which will build the difference between what you know and what the competitors know, and then make a difference from this extra information that you can get out of your data. Even within vanilla retail banking, things become even more better when you have a lot of personal demographic information, and you could use that to build specific banking products which are tailored to the kind of needs that we might have. So if you notice what has run through a common thread across all these three things that I just spoke, it's the role that analytics is playing on top of data that's already there, or organizations are trying to collect more and more. Let me ground this by taking a very, very specific example. For instance, if you have, say, Disney Hotstar, right? So on the face of it, what is your product? What is your what is the place which gets you revenue? It's your main website. And if you now look at the same website, it's probably something which you're already using, probably something which you log in every day, watch your content. And if you now break this down into the analytics components of this, what happens when you typically log in? The login module here on the top right that clicks in, if you have logged in for the first time, it probably goes through a login process, but otherwise it directly logs you in. Then there is a banner promo content that is loading up, right? If you scroll down further, there is a latest and trending bar. How is this actually getting populated? This is getting populated by somebody is running a query saying the moment you logged in, what are the most watched movies? What is the most watched shows? And both of these are simply queries, and most probably written in SQL, where lot of tabular data on when I log in, when did I start watching the video, when did I stop watching the video, and all of this is getting stored in tables, and you aggregate those and pull out which content is having most watch time, and that is what is getting populated here in real time, right? So this website is running a query at the backend, data comes through, and then this gets populated. If you look at further down, right, and there are movie recommendations, how do these get built? These are all machine learning algorithms that are linked to who has logged in. So what shows up here is very different for you, and the same thing will not show up for me, because somebody has written up a personalization algorithm which knows exactly the kind of viewing behavior of the user that's logged in and what kind of content actually appeals to them, right? So if you break this whole thing down, the revenue generating part of the business, you will see that analytics is sort of sprinkled all across the product, right? So if you imagine there was no analytics on this page, which is powering the things that we just saw, right? Everybody in India who logs into Hotstar will see the exact same homepage. There will be absolutely no difference if I logged in or somebody else logged in. And Hotstar will not be able to justify the packages that we are subscribing to. If somebody who's really interested in watching action movies, then that's what should populate my screen. That will not happen if the world of analytics disappeared. So there is real business value, tangible business value, which comes out of having analytics, and this is why organizations are investing so much on analytics. And if you see most of this page, right? So if you break this down, actually heavy duty machine learning is not really the main source of the things that you see on this page. It's mostly vanilla analytics. You need things to work smoothly, which means you need the devices where users are actually logging into your product and your backend to fit seamlessly. So this probably has clarified or thrown some light into why suddenly there is a lot of interest among organizations in analytics, because we are discovering that with and without analytics, there is a certain edge that you can build up, because with analytics, you can build personalization, you can add a lot of value to the user. The user who's seeing your product is much more happier when they actually see something personalized for them, and that's where this whole thing actually shines. Now let me move with this context, right, which is where we have seen that yes, this is important, analytics is important. So how do analysts go about building those models? And I took you through one such example where somebody was actually making a prediction. If I log in, what is the movie that I'm most likely to like, right? It depends on who I am, what kind of a watching history I have, which kind of movies do I see more, which kind of movies do I see less, right? A lot of inputs go into making that prediction. And in this whole field of making predictions based on some inputs that we use is referred to as predictive analytics. It has tremendous value in organizations, like we just saw. If Hotstar makes correct predictions, then it convinces the users to click on, watch more content, and eventually subscribe, right? It is directly linked to revenue. If I make horrible predictions on the Hotstar homepage, then my users will most probably be very angry. Over a period of time, they'll feel that there is no content that is relevant for me, and then they will go away. So it has real impact based on what kind of a prediction that you make. And broadly, predictions that happen in the world of analytics fall into two buckets. They are called regression and classification. I'm going to focus exclusively on classification today, but there is also very classification, in fact, is the bread and butter of the analytics industry. So much of 80% of what we do is classify outcomes. But there is still this important class of problems that analytics solves, which are referred to as regression problems. And here you're trying to predict something which is a continuous value. Most of you are from an engineering background, so you would understand. For instance, if I'm predicting something which is a numeric value, right? Say I'm predicting the number of hours you will watch in a session that you log on, right? So when you log in, Hotstar is predicting, say you will watch now for 4 hours. And I might actually change the kind of content that I show you based on the time you logged in and some patterns you have previously exhibited. So whenever you're predicting the Y that I'm predicting, that's a number, that's when we call this class of problems as regression problems. And in this, some popular algorithms are linear regression trees, and there are a lot of very powerful methods which essentially link inputs to the outcome. For instance, if we want to understand how many marks, this probably is not a great, might bring bad memories, but how many marks will I get in an exam? So it could be the number of hours you study, the difficulty level of the subject, and by using that, I could predict how many marks that you are likely to score. From a business context, like I said, I could be predicting the number of hours you watch. Another real example, which businesses like Swiggy do all the time, is they predict how many customers will place an order in the next 20 minutes. Right? It's a very critical problem as a business because you have a pool of say 100 drivers or 100 delivery partners. You're trying to predict how much demand I'm going to generate so that those 100 could be efficiently allocated. If you're forecasting or if you're foreseeing higher demand than usual, then you have to pull delivery partners from somewhere. So these are mission critical. Directly revenue will come to you or go away if you don't have those delivery partners ready to fulfill the orders. So many places where directly this gets used. Regression is often used to predict a numeric outcome. There is, like I said, a huge class of problems that is very popular in the industry, and that's all comes down to classification. Classification problems are when the outcome y is not a number, it's a class. For example, instead of predicting how many marks you would get, I could predict whether it's a pass or a fail, right? So one of two categories. I could say one is a pass and zero is a fail, and then that could be the outcome. So the inputs remain the same. They could be numeric or um, or categories themselves, like for instance gender, but the outcome is not a number. So the only difference between regression problems and classification problems in this context is to do with y, right? So the same problem, which is on the left, using the number of hours you study and the difficulty level of the subject, I could predict how many marks you get. Or using the same inputs, which is the number of hours you study and the difficulty level of the subject, I could predict whether you fail or you would pass. Once again, many algorithms exist for classification. I will take you through logistic regression in this session. I'll do a couple of demos, like I said, but there are many more, and neural networks and others also are very popular to do this sort of analysis. This is okay. So I hope I gave you a flavor of what classification is all about. But let me actually show the workflow in terms of how does it work in terms of analytics practice. For some reason, this is the way it works is this is good, right? I told you there is a set of algorithms that do classification, where essentially you're trying to predict, given an input, what is the output, right? So, but if you are a data analyst, or if you are a machine learning engineer, or if you're a data scientist, how do you solve the same problem, right? So typically it proceeds in three steps. The three steps that are there in front of your screen. The first step and the most critical one is where you go and actually collect data, right? If I'm trying to predict, for instance, I'm going to now try and predict. I'm going to try and predict, given a set of images. Say I have these handwritten Roman numerals. For instance, I have the letter 1. Right? These are some images that I have, one category. So let me name them 1. So you can see that I'm actually collecting data. This is not something that will be given to you as an analyst. You will spend most of your time trying to collect, clean, process, and ensure that you have representative data for this class, right? So this is one class, which is the Roman numeral 1. You can see the images are dirty. The images have all kinds of marks. Some of them are not even correct, right? So this is a 3. So much of the time that an analyst spends is actually pouring through the inputs and ensuring that they are all correctly captured. Since we are going to do a logistic regression, and by default, logistic regression works on only situations where there are 2 possible outcomes for an image. So in this case, the image could be only 1 or a 2. So let me also pull in the 2s. So these are all, somebody has handwritten them, and again, they are not clean, right? And this is what you should expect. You should expect that data is not going to be a neat, sheet of Excel having the things that you want. It could be having a lot of noise. And this whatever I just did, which is to run through the input data and ensure that it is representative of the label that I'm going to predict, is usually 80% of what we do. So 80% of the time spent collecting data. You can see I've collected about 260 of ones, handwritten ones, and 157 of handwritten twos, right? So 80% of the time you should expect spent on doing all of this. In the world of business, of course, is to make it little interesting. I chose images, but in the world of business, this input data is all could be tables, right? It could be transactions. It could be it could be the time spent. It could be customer ratings. It could be survey data. Whatever it might be, the most of the energy is spent in getting things to a point where you can actually estimate a model. So the second step is where you take all of this data. Like I said, we are trying to distinguish between this class handwritten digit 1 and 2. So ultimately, the aim is if you show the show an image, if this is what is the image that's shown, the algorithm should recognize that this is a 1, and if I show it 2, it should recognize that it is 2, right? And that's the ultimate aim of doing all of this. So second step in any analytics or any sort of a machine learning task is this, which is to ensure that you build that understanding, which is if you show an image, what is it actually? And then finally, once the training is done, step 2, which is usually the most easiest, as in we already know what kind of algorithms work well for what kind of data. So this part, in fact, is the most simplest. The final thing is to actually deploy it on Hotstar. Somebody actually has done this entire process. They've collected customer information, their likes, their dislikes, and they have implemented some sort of an algorithm which takes into account these various the various features of what users like. For instance, I might so a typical algorithm, for instance, which Hotstar might have embedded is if I so it's me, then I have a friend, and the friend also has another friend, and this friend and another friend, both of them have liked the movie, and this is why this is getting recommended back to me. So I am using some sort of a rule to say that should I show this movie yes or no, right, 1 or 0 to a certain person who's logged in, then that is all encoded into a certain rule that got learned by collecting a lot of data and then building this model on top of that, which is what I have done, right? So this next, the final step, once you've got this knowledge encoded down, is to actually test it out. So that's the third phase. So if I have this whole data, then I try to show a test image. Let me try to reach my, these are ones that the model has never seen, and let me try to see if it can accurately guess. For instance, if I give this a 2, and if I ask what is this, it is able to actually say that it is 1. In this case, it's not, right? If you were a human, it is telling me that with a 91% probability, 91% chance, I'm sure this is a 1, which in this case is not at all true, right? So the third step is when it goes through a testing phase, and the real accuracy. For instance, if I give it this, right, it is again very, very sure that it is a 1. Let me give it something which is probably this, right? So it is again sure that it is a 1. Let me give it a 2. This is again a typical step that we do. It is once a model is built, we run a lot of tests. It's 100% sure that it's a 2, right? So if I break this down, right, whatever be the algorithm, these 3 steps are going to remain the same. Step 1, you collect clean data to bring it to a shape where you can use it. Step 2, you build a model. You build a model that encodes the relationships between what you're trying to predict. In this case, I was trying to predict whether the image was a 1 or a 2. And then step 3, where you test things, whether you check whether what you've learned is accurate, how accurate is it, how many times if I show it a certain digit, is it actually predicting what I want? And the final thing is to actually go on and to deploy it. So in this case, if I want to deploy this on, say, on somebody's phone or on a website, I typically export this and then I embed it into the website's code. And then whenever somebody loads the page, this model that I've just trained, it loads up and then it starts making predictions. And irrespective of whatever the model, this process remains the same. So while classification is, one of the popular methods, the process that you follow once you're doing analytics day in, day out is just this three-step process. You collect data, you clean it, build a model, make a prediction. Now, let me take you through this specific algorithm, right, which is logistic regression. I showed you the workflow of what a typical analytics person would do. Now, let's see what this specific algorithm, which is logistic regression, is all about. This one actually works only when you have two possible outcomes for Y. So it could either be pass, fail, it could be 1 or 2. That's the model that I just built. Or it could be any other situation where Y has only one of two options. So it can either be 1 or 2 and nothing else, right? So that's sort of a scenario. Of course, there are also other scenarios where you have more than one choice for Y. So there could be, like if you want to predict the weather, 3 or more choices. This algorithm does very well, specifically when you have just two outcomes. Like I said, even though this I think was discovered and established in the 1950s, a lot of application exists in the world of business, and that's where I wanted to start. A lot of banking industry uses this algorithm a lot. E-commerce as well. I've tried to show you one. Healthcare as well. Let me give you an intuition of this algorithm rather than giving you a bit of math. And I'm going to again take you through, let me load that, the demo. So the way this algorithm works, right, if you see on the right, there are two colors of dots, one with orange and one with blue. And there are two axes, x1 and x2. And think of these as two classes, right? This is ones and these are twos, right? Each of them, or these are the people who clears an exam and these are people who did not clear an exam. And that is dependent on two things, like people who don't study that much and people who and the subject is very, very tough on a scale of say -6 to 6, right? So if you have data that looks like this, which means I can separate these two using a straight line, that's where logistic regression is really, really nice. The finally built model would be, if I get a new point, it will figure out which side of the line is it in. If it is on the blue side, it will say you're blue. And if it is on the red side, it's going to say it is red. The way it works is it starts with a random line and it will initiate something like that. And then it will see, am I making a lot of mistakes here? In this case, it's clearly making tons of mistakes, right? Everything here on this side of the line is not blue, and this is supposed to be red. That's not correct. So I can change the line a little bit and change it more and change it more till I reach a line which is perfectly separating these two classes out. So that's what this algorithm tries to do. And if I try to do the same, you can see that it's started to learn. You can see that the input data is getting fed into the classifier, the logistic regression classifier, and it is over a period of time trying out many lines. It has tried out about 900 odd lines, right? It's running thousands of times, and you can see that there is no change in this line. It is able to perfectly separate these two classes because you can put a line sort of between these two. So we started with data and we are left with a line, right? Now, if you give me new data, then all I have to do is to check where, which side of this line does the point lie. If it lies on this side, then it's a blue. If it lies on this side, the other side, then it's red. So essentially, logistic regression amounts to learning a line, right? It's just a line that we learn by changing the orientation, the slope, and the intercept again. So when your scenario is like this, then logistic regression does brilliantly. But what if your data looks like this? And this is a challenge. Can you put a line which will separate these two classes, the blue and the red, exactly? And let me try to do a few, right? If I put a line like this, everything on this side is not really blue. Everything on this side is not really orange. And whatever I do, right, wherever I put the line, whatever I try to do in terms of orientation, I will always have a mix of reds and blues on both sides. I'm not able to linearly separate the two classes, and that's what will happen even if I run, right? So it's struggling to change the line, change the line, change the line a lot, but it is not able to. When it does, let's wait till it does say 1,000 attempts. It is sort of converging to this line where this line where the accuracy is not that great, right? So it is it has if this really worked on this side of the line, everything is supposed to be blue, and on this side, everything is supposed to be orange. It has worked out here. What it has figured out is that one line, which is everything below this line, it is orange. So it has sort of figured that out, but then there are some points here. It has missed out some smattering of orange, which is there on the other side of that. So what I've done is given you a flavor of two things. One is when we say you're working in analytics, what do? Right? So you collect data, you clean, prep, you bring it to a shape where you train a model. Training model amounts to estimating the best way in which you can differentiate between the two classes that you're interested in. This is what we just saw. And I went deep into one model, giving you an intuition around what exactly is this whole training business all about. And irrespective of how complex the model is, right, it still comes to the same thing. Given a set of input data, can I fit the best model that discriminates between two? And this is where logistic regression is used. Once you train it, then you export, and then you use the model. So, by way of summary, logistic regression is a classification method, which means the output is a prediction of whether it is a red or a blue, whether the customer will subscribe or not subscribe, whether they'll click on an ad or not click on an ad, whether they will click and watch the video or they won't. And all such kind of methods are all classification. Logistic regression is a good baseline. It uses a linear decision boundary, as we call it technically, but essentially you are trying to squeeze a line between two classes. Whenever you can, it does very well with very high accuracy. In real life, that might not always be true, right? So that's why it's a good baseline. It's not the best model, but it still does well in many, many situations. Hopefully this gave you a flavor not only of the methods, intuition around what exactly classification is all about, but also gave you some sense on the kind of workflow that usually analytics requires, right? You broadly require the ability to manipulate data, which means it could be images, it could be audio samples, it could be tables, it could be whatever be the input data. You have to bring it to a shape where then models could be built. If you are a data engineer sort of a profile, then you will spend most of the time trying to understand how your database is built, what are the relations that exist there, use SQL or some other flavor of NoSQL to ensure that the data is properly assembled so that you can make predictions downstream. If you are a pure data engineer, your role will end by just accumulating the data, which is step one of that entire analytics workflow that I showed. If you are more to the modeling side, ML, or you're a consultant, then you will spend a lot of time taking the data and building kind of models that we just saw. Most important is also the awareness of the different domains, because you might actually use that to build better models. You might not need logistic regression at all. You might need something else which is either far more complex or simpler based on what you think is the is important in the domain. To give you an example, when Instacart was trying to make predictions around how many customers will be active in the next 5 minutes, which is what they used to manage their delivery partners. All they used was how many are currently on the app who are trying to place an order, and an estimate of what are the number of products that are there in stock and where they are, right? So very simple. So you don't really need complex solutions if you know the business well. So understanding of the business domain, very highly rated. If even if you are not that proficient with data, but you have the knack of asking this question, so how do I translate this into a business scenario? How do I break down my existing business into components which will work better when I sprinkle analytics? That is also very highly valued. Of course, nothing works without tools, right? Python has become extremely central to the workflow of a data analyst today, or an ML person today. If you know Python and SQL, that itself is going to set you far apart most of the folks who are trying to apply to the same role. If you are in a business facing role, then understanding how to present data either through Excel or Tableau, which are again popular tools, are also highly valued. Ultimately, you have to tell a story through your analysis, which is what I've tried to also showcase. It's not just about the maths. There was no maths today, right? I didn't even share the equation, but the ability to tell what exactly and what you're trying to do through visuals and very robustly conducted analysis, irrespective of the kind of audience that you have, is also highly valued. So what if you do all of this, right? So what if you pick up these skills? What kind of roles are we seeing which are becoming more and more important? There are these, set of roles which are getting very popular. Whereas the business analyst sort of roles, typically they work with the product teams, understanding what kind of processes are working better, trying to recommend solutions based on data. So it could be that the product team launches something, they think that something is not working well because of whatever reason, and the business analyst can actually look at the data and say, this is the pattern and this is why it's not really working. Data analyst as well. So here you're more closer to the data side of things. So there is no specific problem that you're trying to solve. You're looking at data, inferring patterns, and trying to help decision making within the organization. So you're, as a data analyst, more aligned towards the management side of things. Business analysts typically tend to work with product teams and individual process owners. If you eventually do this for a while, 3-4 years, and then you graduate to be a manager where you handle 2 or 3 reports who are all analysts. One more field which is picking up a lot of analytics professionals is, of course, management consultants. Even the big ones like McKinsey has a specific data consulting arm, separate, which works exclusively on situations where there is a lot of data or difficult data, but otherwise as well. Pick any management consultant and they will have an analytics practice. And that's where, again, knowing how to get data, build a model, and make a prediction is very valuable. Product owners as well. If you are the owner of the Hotstar homepage, you are constantly looking at what is working, what is not working, what kind of what improvements can I do to the analytics portions of the website to improve the performance of my website. So that is also very crucial. Operations guys, where if you're looking at what processes in my business need a lot of care and very fine-grained analysis on data that is coming from various inputs. It could be sensors that are there on the assembly floor, a lot of places where data gets collected. Can you come in as an analyst and put all of the data together, explain something or predict something, predict that the way our production pattern is, we will have a maintenance breakdown, say in the next 3 weeks. And that is extremely valuable from an operations point of view. So So you can see that there are some roles which are like central. All you do is analyze data and make predictions. There are some roles where you are aligned to a stakeholder, some roles where you are entirely managing teams of your own. Let me close with an overview on on our program. So, if you have heard me so far, you've probably got a flavor of what it takes to be an analyst, and that's what we've done. As in, there are several of our learners who've gotten placed. A lot of feedback that we get from that process itself, and we've sort of worked backwards and said, if this is the role that one is aspiring to be, what can you pick up, and can we put all our expertise in terms of industry mentors, in terms of millions of hours of learning that we've delivered and presence across geographies to build something which is valuable for somebody who's an early career professional. So if you're coming out, and most of you here with me today are sort of in that profile, who are looking to either transition to this or who are looking to aspiring to be an analyst role, it probably have given you a flavor of what it is like to be actually in that role, and what should you expect once you once you become one. There is this program is designed to bring up anybody from 0 to 3 years of work X to be up to speed, as to be working with data, high volume, low volume, whatever be the quantum and quality of data, but that is what you will be equipped to deal with. We have seen tremendous traction in terms of both the placements that they get, and also depending on the experience that they have and the kind of skill set that they demonstrate. We have seen like very huge jumps in salary as well. So a lot of care has gone into putting together this 16-week program, which focuses on data analytics, which is what I focused on today. But then I've also told you that real life products also need development of software, also need testing, right? So those are equally important. A Hotstar homepage will not run just because you have built a great model. It needs to be deployed and then used by a lot of people after it's been tested, and that's where skills and software also are as essential. So put these three together, and then you are ready to take on the challenges that that businesses in the real world are today showcasing. With this, I've come to the end of what I wanted to share. But like I said, I have Shahrukh and Karan with me, and they'll help me to answer any questions that you might have. Please feel free to put it in the Q&A box that you have. It could be something that I've touched upon in terms of concept, or in terms of roles. Whatever is there on your mind, now would be the time to ask me whatever is there on your mind.
Thank you, Dr. Pawan. It was actually a lot of knowledge and a lot of insights for anyone who's looking to get into the data analytics sides or the data science side. Because ideally, a lot of people, okay, we just scroll and then we go through a couple of websites, but we don't really understand what is the engineering running behind. So I hope our learners, you must have got a good amount of insight regarding this program or regarding how data analytics or data science works. Now, since a lot of you are students of final year and 2021 pass out who's looking to start their career in the field of data science or data analytics, we would like to take your questions so that we can help you in the right way. So we have a question from Harshit where he says that he's a fresher, and a postgraduate student in statistics. Please tell me in which would be a better for me to be a risk analyst or a data analyst.
Good question. So, Harshit, let me answer it this way. It's probably easier for you to get your first job as a risk analyst, but you'll be better placed in terms of future if you, sort of position yourself as a data analyst. So financial BFSI is like looking at a lot at risk at the moment. There is a lot of attention around traditional roles in risk, right, which is in banks and financial services, which is good, which means you have a starting point already, right? Statistics is very, very highly valued there. If you can add a little bit of flavor around actually handling data and delivering products, right? Then that can, in fact, even within the risk profile, can actually give you a jump up in terms of what you can earn. But as you go along, as in look, I mean, getting into this for the future, I think either immediately or as you evolve, look if you can pick up some skills around either implementing things in software or work more towards the models. As in, if you're building something, some risk model, can you use that similar flavor of a model in another domain, and then you sort of become more. Your knowledge becomes richer, and then you become a data analyst. So, a short answer is probably your best. It'll be easier for you to get a job as a risk analyst, but then placing yourself broadly, even if it requires a little bit of training, is probably future-proofing your knowledge.
Harshit, I hope that answers your question. Okay, Dr. Pawan, we see a lot of students who are from BCA and BCom background. So they wanted to also check whether they can start their career in the side of data analytics.
Right. So that's a, valid point, right? So you're not necessarily from data heavy, not even probably in engineering heavy sort of a role, right? So the key thing, right? If I go back to my to our slides, the extremely key thing here is that understanding the domain, right? What moves profit or revenue in a business, that in fact is equally or more important than actual mastery over a certain programming language or the ability to handle large amounts of data, because not every business is a Google size problem, right? Not everybody is having like millions of users on their website or on the search engine giving you tons of data. It is true that they get a lot of, what you hear often is the huge AI/ML innovations that these big companies are doing, the Facebooks and the Googles of the world. But much of the 99% of the businesses actually need people who understand the business, which means if you are somebody who already understands to some extent the world of business, and you can put the effort to pick up analytics on the side, then I think you're really positioning yourself for a broader sort of a role. You're not necessarily losing anything that you already have, but then you become much more powerful. So in terms of actually, the question there would be like, how easy is it or how difficult is it to pick these things up, right? So I'm pretty sure that if you're coming from a commerce background, Python is, I don't think might have already seen Excel, but I don't think Python is something that you would have seen. But what we have seen in our own experience is it is definitely difficult in the beginning, the first few weeks when you're trying to figure it out. But once you do, right, the kind of code that we write for analytics is not the same as the kind of code that you write when you're like developing an entire app or developing an entire website. It's completely different. We don't count ourselves by the lines of code we write, but the effectiveness of that code. And if I look back, I don't like thousands of lines of code. It's just that do you know how to actually apply it and translate it into a few lines of code? So it is difficult to start off, but then that learning curve tapers off, and then once that initial difficulty is crossed, then you chug along. That's what we have seen. So if you're somebody who's coming with a commerce background, who's intently looking at how does changes in how does analytics help my business, right? And we're going with that view because that's what people will really want to know. It's how does it improve my business? And on that front, commerce or any other background is like on equal footing, right? So what is so good about having an engineer who doesn't really understand that feature X actually adds more revenue while feature Y does not, and they don't know how to practice. So there is a learning curve, but then if you cross that, then I think tremendous growth awaits.
Absolutely. So I think more importantly for anyone who's looking to get into data space or data science, of course, while you're working for a company, you are actually working for the business for the company.
Correct.
So it's important to understand the business language rather than getting into the nitty-gritties. But of course, yes, working on tools and of course getting a hands-on is something which you have to do in course of time so that you become well equipped and have a better productivity for yourself.
Correct.
Harshit, you have raised your hand. Can you please help us with your question? Okay. So with this, we would like to conclude our webinar for today. So students who are or aspirants who are willing to get into the space of data analytics or data science for to start their career or to look for a career transitions. Great learning in collaboration with the multinational companies which are there and the hiring partners which Great Learning have. So we have launched a program for data analytics and software development, which is a backend software development, where it is an in-house classroom program where you would be coming on Monday to Friday, sorry, where you will be giving us every day around 5 hours of your time so that we can help you to get skilled to get into these companies. The classes will be at HSR campus, which is a classroom campus of Great Learning. So typically right now, DSC, AIML, DSB students are joining there or they're taking their classes. But yes, for anyone who's looking for this program, which is into data analytics or data science space, we would be there to assist you here, which is a 16-week program. This is going to start in the month of August. And then for the next 4 weeks, 4 months, you will be working with us where we will be working on hands-on projects as well as a lot of theoretical concepts, giving you access to certain tools so that you have a fair understanding how these are getting implemented or how these projects are getting implemented in the industry, so that post this 16 weeks of time, you are job ready and you look for the right job. So for that, we're going to help you to get into one of our partnered companies. So Great Learning has more than 8,000 companies partnered with us. So we're going to help you to get into these companies with 10 guaranteed job opportunities. The salary range, of course, is going to be from the range of 3.5 to 11 lakhs. Now, you have to quantify this because we're going to expect around 400 hours of your learning content. And of course, around 100 to 200 hours of self-learning, which has to come from you. So if you are someone who's willing to invest your time here, we're going to train you for this program. For anyone who's looking to know more about this program, I'm going to share the application form for this program with you so that you can share your college marks with us and your 10-12 marks so that accordingly we can collate this so that we can figure out which are the right companies for you and accordingly train you for these programs. This program is going to start in the month of August.
I think we've lost.
Dr. Pawan, thanks a lot for joining us here. I hope our participants must have got some insights how to start their career in the field of data science and data analytics. But yes, as rightly mentioned, you should have the skills to understand the business language so that you can look into this field and of course get skilled towards these tools and technologies so that you can come up the ladder for any companies which you are looking forward for.